Okay, we're going to talk about polynomial functions and models. This section is not that hard. There's just a lot of little things in there. So make sure you know your power functions. The first one we have y equals x cubed and y equals x to the fifth. The green is y equals x to the fifth. That's this one here. It's just like y equals x cubed, but a little narrower and then wider at the origin area. What you need to know about this is something called end behavior. So when you talk about end behavior of a power function, these are power functions. I'm talking about end behavior. What we're talking about where it starts and where it ends. So the end behavior is that we're starting, this part goes down and it's going up in quadrant. So we're looking at quadrant 3 and quadrant 1. Starts in quadrant 3, goes up, and ends in quadrant 1 for both of these. Now for, you already know x squared, so this one, let's just make something up, something like that. That's x squared. X to the fourth is merely, it's just a little wider in here, but a little narrower in here. So just a general idea. Main thing we need to know though is about end behavior. So if your power function is one of these, our end behavior is it's this way. We're starting in quadrant 2 and we're going to end in quadrant 1. Now, if you have the reciprocal or the negative part, so for example, if we have y equals negative x cubed, then that one is here, reflects this way. It's an odd function. So if your polynomial you're forming is negative, that means the end behavior is this way. You start here and end here. And the same thing with the, let's say, x to the fourth. X to the fourth would be reflected over the y-axis. So your end behavior looks like this. That's what they mean by end behavior. And there's a better example in your book. So let's talk about these and do some that are in the book. I'm going to do, they want you to form a polynomial with, let's make this graph paper. Alright. They want you to make a polynomial with the zeros, negative 1, 1, and 3. They say the degree is 3. So that means the power function is y equals x cubed. So the zeros are, and we're going to write it as f of x equals a. A means that vertical stretch part. In this case, our a is going to equal 1. So we're going to have x minus a negative 1 times x plus 1, no, x minus 1, sorry. Let me erase this, minus 1. It's just like your quadratics, x minus 1 and x minus 3. Which is basically, if a is 1, we're just going to get x plus 1 times x minus 1 times x minus 3. Now when you FOIL these out, do the two that's easier. We know that this has the form of a plus b times a minus b. So we know this is a squared minus b squared. So this part right here yields us x squared minus 1. And we're going to FOIL that with x minus 3. And we're going to get x cubed minus 3x squared minus x plus 3. So basically, I just FOILed first, outer, inner, last. And there's your polynomial, where your a is 1. Okay, There's also the thing they talked about, turning points. Our highest degree is 3, so our power function, as we said before, is y equals x cubed. This means we have at most n minus 1 turning points. Since our n is 3, then we're going to have at most 2 turning points. And I want to just sketch the graph here so you kind of see what's going on. So let me sketch the graph and let you know what's happening. Alright, so basically we have a 0 at -1, which is about here, and 1, and 3. Also, our power function, like we said on the first page, is x cubed. So that means we're going to start in quadrant 3 and end in quadrant 1. So we're going to start down here and draw it this way. So I'm going to go through here. I know my y-intercept is 3. I know I crossed there somewhere. So I'm going to start down here. I'm going to kind of make it narrow. Go down here. Cross again. I'm not going to worry about the min and max, the exact values. We do that with the calculator. We're not going to worry about that right now. But at most we had 2 turning points. That's your polynomial. It's easy to graph if you know your zeros and you know the power function, because you have to know the end behavior. In this case, this was our end behavior and we did it here. Okay? Alright, so let's do another one. We want to form a polynomial for, let's see, we have zeros, -3, 0, and 4. The degree is 3. So our power function is y equals x cubed. That just tells us our end behavior. I form my polynomial f of x equals, what is this? Anyway, let me write it again. Alright, f of x. So I'm going to write x minus a -3, x minus 0, and x minus 4. Now, if you will, what I'm going to do is take care of this one first. X minus 0 is just x. Then we're going to have x plus 3 times x minus 4. Now, in this case, I'm going to go ahead and FOIL that out. This is just going to be x. So then I'm going to have x squared minus x minus 12. Again, this is f of x. And distribute the x. So I have x cubed minus x squared minus 12x. This all equals the same. Now I'm going to graph it again. How many turning points do we have? Well, since my highest degree is 3, I know I'm going to have at most 3 minus 1 turning points. So I'll have at most. I could have only 1. But in this case, we might have 2 turning points. Alright. We might have 1, but we're going to have 2. So, my power function means I'm going to start down here and end in quadrant 1. And my zeros are -3, 0, and 4. So 1, 2, 3. -3, 0, and 1, 2, 3, 4. I start here. I'm not going to worry about high, go here. I just know I need to come back down, and come back around. And my 2 turning points are right here. That might not be the exact value here, but right now we're not going to worry about that. And there's your function. Alright? Let's do one that has multiplicity. So let's do zeros are -1 and 3. This has a multiplicity of 1, and this one has a multiplicity of 2. The degree is 3, So my power function is y equals x cubed. Now, when we look at this, my zeros, that's going to be f of x equals x minus a negative 1, which is x plus 1, and the 0 is x minus 3. Multiplicity 2 means I'm going to square that. That's what multiplicity of 2 means. Now, in this case, multiplicity of 1, that just means it's the first power, which is the ones we did before. Now, when I FOIL this out, what I'm going to do first is this part, because I know this has the form of a minus b squared, which we know is a squared minus 2ab plus b squared. So I'm going to go ahead and take care of that. That's going to be x squared minus 6x plus 9. And then I'm going to have to multiply it by x plus 1. And I'm going to get, I'm going to move it over here. X cubed, no, I'm going to move it over here. X cubed minus 6x squared. This is not that hard. And then the 1 just means you just write the same thing down. 1 times x squared is x squared. 1 times negative 6x is negative 6x. And then you have your 9. And is there anything I can clean up? I can combine these two. And I can also combine these two here. So when I simplify, I'm going to get x cubed minus 5x squared minus 3x plus 9. Hope I did that right. X cubed minus 5, yeah. Okay, so now what we're going to do is I'm just going to graph it. I know that, and this should have had an a in front. My a equals 1. That means there's the vertical stretch is 1. Kind of going to graph it over here. It has at most 3 minus 1 turning points. And let's look and see what happens here. Now, my zeros are at negative 1, which is about here, and 3. No, I don't like this. Let me erase this. I didn't draw this very well. Alright, let me draw this a little straighter. Alright, so 3 would be about here. And since the power function is y equals x cubed, it means we're going to start here, down here. Our y-intercept is 9, so we're going to be way up in here. I'm just going to go up high. And I'm starting here. I cross, because the multiplicity is an odd multiplicity, all the way to 9. When I get down to 3, I don't cross, because that's an even multiplicity. So if it's an even multiplicity, it doesn't cross, and it goes up that way. And that's your graph. And remember, when we have, when we graphed, this is y equals x squared. At that point, it just touches. It doesn't cross. But when you have y equals x cubed, that's an odd multiplicity, and that does cross the graph. So that's a good clue right there. Okay. Now, let's do another one. Let's do one where we're just going to graph, we're just going to look at it. So let's look at, I had one that I wanted to do. I'm going to do a hard one here because it's already been 14 minutes. So I want to do this one. We're going to do f of x equals negative x squared times x squared minus 4 times x minus 5. Now let's analyze this. First of all, I know I can kind of rewrite this part a little bit, so I want to rewrite that again. We have negative x squared, x minus 2, x plus 2 times x minus 5. Now how many x's do we have? We have two here, so that's 2, 3, 4, 5. So the power function is y equals x to the fifth. And we know what that looks like, but our a is negative. So we know our power function, y equals x to the fifth, goes like this. But y to the negative x fifth to the fifth goes like this. So my end behavior, we're going to start in quadrant 2 and we're going to end in quadrant 4. Okay? Now my zeros are 0. With multiplicity of 2. That's this part. 2 with multiplicity of 1. The rest have multiplicity of 1. Negative 2, multiplicity of 1, and 5 with multiplicity of 1. So if I graph this, how many turning points can we have? We can have at most n minus 1. So my n is 5. 5 minus 1 equals 4. We can have at most 4 turning points. So let's see what happens. My y-intercept, do we know what that is? Oh boy, I don't want to worry about that. So what we're going to do is do our zeros. We have 0 here at 2, negative 2, and 5. So that's 2, 3, 4, 5. Now remember at 0, we just touched the graph. We're starting in quadrant 2 because we're going to use the negative part. So this is our power function here. We're starting here. We're going to cross, then come back up to 0, and it's not going to cross. We're going to come back down, come back around. Again, I'm not going to worry about the exact min and max there. And then we go back down here. So it's something like that. And how many turning points did we have? We have 1, 2, 3. So we didn't have 4. We had 3 turning points, but the rule is we're going to have at most n minus 1 turning points. Okay. And it's as simple as that.